All right, here's another example. Again, using the speed of light is equal to the wavelength times the frequency. Let's do a problem where we try and solve for the wavelength, okay? Let's try and do one of those. So let's say that we have a frequency that's equal to 2.57 times 10 to the 20th per second. Let's figure out what the wavelength would be for that. So we're looking for lambda. So if the speed of light is equal to the wavelength times the frequency, the wavelength is going to be the speed of light over the frequency. What's the speed of light? 3.0 times 10 to the 8th meters per second. And what's the frequency? 2.57 times 10 to the 20th per second. What unit cancels out? The per second cancels, and it leaves me with what unit? After that is gone, leaves me with meters, which is a unit of wavelength. It's a length. So when I do this on my calculator, I get 1.2 times 10 to the negative 12th meters. Now, if I wanted to convert that into nanometers, not a big deal, right? I mean, this is a good answer unless the question's asking for nanometers. But if you want to convert it to nanometers, 1.2 times 10 to the negative 12th meters, right? What's the conversion between meters and nanometers? There's 1 times 10 to the 9th nanometers in 1 meter. So when you do this math, you get 1.2 times 10 to the negative 3rd nanometers. That would be what it would be in nanometers. If the question's asking for meters, do it in meters. If it's looking for nanometers, you got to do this. But this is the answer. This is how you do it. So I hope that this helps you to understand how to use the speed of light equation to figure out wavelength and to figure out the frequency.